This video deals with significant digits or significant figures. The subtopics that we will treat on this will be: what does the significant digit represent, how to identify the correct number of significant digits, and how to write the final answer when we are operating with uh, data collection or numbers that have different significant digits. So that is according to the significant digit, representing the correct number of significant digits. The very first thing that we will discuss is what does the number of significant digit represent. So the number of significant digit represents the precision of the instrument that you are measuring or the data collection that you are. How precise is the measurement that you have either completed in an experiment or during an experiment, or it's given in your question. So the precision of it. Now, how to identify the number of significant digits? There are several rules that we apply for the identifying the significant digits. So the first rule is that every non-zero digit is counted as a significant digit. So if we have a measurement that has 3.25 meters, let's say, then the number of significant digits for this measurement is 3. Because what we have here, what do we see here, is all the digits are non-zero digits. However, when we have zeros that are between two non-zero digits, they are counted as significant digits. They are holding the place of that measurement, so they are counted as a significant digit. So when we have a number like 7.02503, then all of those zeros that are between two non-zero digits are counted as significant digit, and on this case we will have 1, 2, 3, 4, 5, 6 significant digit or significant figure. Both of them are used in the world of science, so sometimes I will write sig digs or sometimes I will write sig figures. It is the same thing. However, when we have the leading zeros, then those are not counted as a significant digit. So if we have a measurement that is 0.0, let's say 73 kilometers, you can easily express this as a 73 meters. So the number of significant digit on this case is only 2 sig digs. So leading zeros are not counted. But if we have something that is 0.07302 kilometers, then this number can be expressed as 73.02 meters, which means that on this case, the zero that is between two non-zero digits is counted as a significant digit, and then you have 4 significant digits for this measurement. Okay. Zeros after the decimal point also are counted as a significant digit. So if we have a measurement that is 12.0 milliliters, then that means that the zero that is after the decimal point, even though that mathematically this doesn't have any effect, in the world of science is expressing that the measurement that you have for the measurement that you have used for this particular instrument that you have used for this particular measurement is to the precision of 0.0 milliliters. So in this case, we will have 3 significant digits. Okay. This is pretty much what you need to know for a significant digit. Now, another thing and note that you have to keep in mind when you're, especially in the world of science, when you're dealing with pH or POH, the significant digits are counted only the digit as a digit after the decimal point. So if we have something like 7.43 for the pH or POH, then the significant digit on this case will be only 2, because are only counted the numbers that are after the decimal point. Or if we have a 3.804, then the number of significant digits on this case is only the digits that are after the decimal point, and this will be 3 significant figures. Now let's see how can we determine the final answer correct to the significant digits when we are adding and subtracting. So the rule for adding and subtracting is that what we will do, we will write the final answer to the lowest number of digits after the decimal point. So let's suppose that we have something like 3.825 plus 2.21 minus 8.021. Then if we are using the calculator, then the calculator will give us a number as negative 1.986. This is what the calculator gives you. However, the final answer should be recorded to the lowest digits of after the decimal point. So this first number here has 4 significant figure. This number here has 3 significant figure, and this number here has 4 significant figure. However, the number that is with the lowest digits after the decimal point is this one here with 2 significant digits. So then, therefore, the final answer will be to reflect the lowest number of digits after the decimal point into our calculations. So we have to stop at this place here. However, since the digit that is left out recording for your final answer, since it is greater than or equal to 5, we will apply the rule of rounding, and then the final answer for this calculation will be negative 1.99, and whatever are the units for it. And when we are multiplying or dividing, what we will do is we will express the final answer to the lowest significant digits of the information that we have. So let's suppose that we have something like this. Let's suppose that we have 3.82 times 2.1 divided by 8.35. If you are using the calculator and you are entering this information into your calculator, then you will have an answer as 0.9607185 and probably more digits after that. However, In our information, what do we have is the first number is with 3 significant digits. The second one is with 2 significant digits. And the third one, part of the calculation, is with 3 significant digits. The lowest number of significant digits in our calculations is 2 significant digits. So then the final answer will be expressed into 2 significant digits. In order to express it into 2 significant digits, since leading zeros are not counted, then we have to stop at 6. Then what do we do is we take a look at the digit that is left out. If it is greater than 5 or equal to 5, greater than or equal to 5, then we round up. And if it is less than 5, then we keep it as it is. So the final answer will be 0.96, and whatever are the units that we are dealing with. This will be the significant digit video.